Hi, so today I have this trig equation on the quiz on the left, and we're going to work this out. And I'm going to do this using, I don't know if you want to call this the Weierstrass substitution T formula. Let's just write that. It's hard to spell. And what this substitution is it's just you set t equal to tan of x over 2. And the reason tricky thing is that you would never think to do that. You don't even have tan in the equation, right? You only have sine and cosine. You don't have half angles. You have the full angle. So it's not very intuitive to do that. But when we do this, what you can do is we can draw draw a right triangle with the angle x over 2. And then for tan of x over 2 to be t, we're going to have t in 1. And then therefore, using the can't pronounce it, but the Pythagorean theorem, t squared plus 1 squared, all squared will be the hypotenuse. So then from that, we can say that sine of x over 2 is going to be t over the square root of t squared plus 1. And cosine of x over 2 is going to be just equal to 1 over the square root of t squared plus 1. And we're getting closer. What we want is we want something to substitute in for our sine. What we want to do is build a substitute in for sine of x and cosine of x, but we have the wrong angle. We have x over 2. So what we need to do is use the double angle formula. So let's start with this. And what we'll say is 2 sine x over 2 times cos x over 2 equals sine of x. Just doubling this angle here using double angle formula. And we know what these values are, so we can just plug in. We're going to have 2 times t over the square root of t squared plus 1 times 1 square root of t squared plus 1. And this is just going to equal 2t plus t squared plus 1. Then we have our value for sine. And similarly, we'll do the same thing for use double angle for cosine. So we're going to have cosine of x. It's going to equal cosine x over 2 squared minus sine x over 2 squared. Again, we just use our values again. For cosine, we'll have 1 over t squared plus 1 squared minus t square root of t squared plus 1 squared. And we're going to end up with 1 minus t squared over 1 plus t squared. That's going to be our value for sine of x. So then we'll come back. Just going to scroll down and we'll use this on our equation on the left. So we're just going to plug into this equation. We have 33. We have our sine value, which is going to be 2t 1 plus t squared minus 13. We'll have 1 minus t squared, 1 plus t squared, and that's going to equal negative 23. Then for the next step, what we want to do, we're just going to multiply through by 1 plus t squared, just going to make it cleaner. So we'll multiply everything by that. And I'm also going to distribute, so I can do this in one step. Distribute here. And what we're going to be left with is 66t minus 13 plus 13 t squared. And then on the right side, we're going to have minus 23 minus 23 t squared, just because I multiplied 1 plus t squared on the right side. And then all I want to do is I want to bring this stuff over to the left. And just write that all out. So we'll have 66t minus 13 plus 13t squared plus 23 plus 23t squared, 0. Just combine like terms. What do we have? We're going to have 36t squared plus 66t plus 10 equals 0. That looks kind of hard to factor a little bit. Let's divide everything by 2. So we have 18t squared plus 33t plus 5 equals 0. Let me think about this. Oh, I think I got it. Okay. The fact sometimes like something like that, the factorization doesn't just jump out. You may have to mess around with it, but let's see. I'm thinking we do 6t times 3t, and we do 5 here, 1 here, plus. Yeah, that's gonna work. Okay, so then we're gonna have our two roots. We're gonna have a root at negative 1/6, and then we're gonna have a root at negative 5/3. And so that is going to give us value for t. Now, so at this point, this is where you kind of want to remind yourself what you're doing, is we just found values for t, and we'll remember that t equals tan x over 2. But we don't, technically we want to solve for theta, but I changed the variable to x just to be tricky. So what we want, we don't want t, we have t, but we want is x. So we can rearrange this, and we can say tan inverse of t equals x over 2, and therefore x equals 2 times tan inverse t. Okay, that's going to be the formula we're working with. So then, to find x, we got two things to solve here. We have x equals 2 tan inverse of negative 1/6. We have x equals 2 tan inverse minus 5/3. What I'm going to do is, they want the answer in degrees, so I'm going to get it in degrees. I'm going to use my calculator right here, though. I'm going to just punch in, doing this off screen. So we want tan inverse of negative 1/6, and that's going to be, let me do a little side calculation. It's going to be negative 9. Say negative 9.5 about. But what we want is, the question's asking for the angle in between 0 and 360. So we need to get this to be a positive angle. What you can do is you can add 180 to it. And I'm going to round to the degree, so we're going to have that at 171. So plus 180 equals 171. And then times 2. And that's going to be 341. Okay, I'm rounding afterward. Yeah, so 341. Technically, if I doubled this, it'd be 342, but we're going to double it, then round. Then let's do the same thing for the second one here. We want negative 5/3. Tan inverse is minus 59. Minus 59 degrees plus 180 is 121. Then we're going to double it, and we get 242. Then come over, we'll check our answer. 242, 341. That's correct. So just want to show that I have this quiz. There's a bunch of problems in here. I have some of them are with like secant, same technique, but using secant and tangent. Um, there's some like this that have double angles in them, so it's a little different, but I have some instructions on how to handle that in the help. And those formulas here that you can use. Oh, and there were some videos from where I kind of got the idea to do this quiz, so you can check that out. I'll give a description. Oh, no, I'm not gonna. I'm gonna give a description, but I'm gonna give a link in the description. Thanks.